The following question reads that the stoichiometry of a catalyzed reaction shown by the equation below. So it's a reversible reaction and it's a catalyzed reaction. So let's underline this, that there is a catalyst added. Two experiments are carried out in which the amount of R is measured. R is one of the products. The results are shown in the diagram. So you can see the two graphs with respect to time. Now the first graph is steeper, so it's a faster reaction. The amount of R, the product that's being formed, is being formed at a much faster rate. It's taking lesser time, so the rise is very steep. So experiment one is faster, whereas experiment two is slower. So this experiment is slower compared to the first one. The first one has also it is complete at this time. I mean, if you look at this line has become straight. So that means that the reaction has stopped. So there's no more R forming. So this reaction has already stopped or has reached equilibrium, which means that the rate of forward and the backward reaction would be equal. But if you look at experiment 2, the amount of R is continuously increasing. So the reaction has not stopped yet. So, or it hasn't reached equilibrium. So experiment 2, the reaction has either not stopped or hasn't reached equilibrium. Now the statements are, he's saying which changes in the conditions could explain the results. So first thing, experiment 2 is a lot slower compared to experiment 1, which is faster. Now the first option is that a low pressure was used in experiment 2. Remember, pressure only has an effect on gases. So let's check whether all of them are gases. So you can, if you look at the equation, all of them are gases. The reactants at least are gases. So that means that pressure is going to have an effect. And lowering the pressure uh, decreases rate. So that makes perfect sense. Lowering pressure, so your particles are far apart, which leads to fewer collisions. So, in my opinion, one makes perfect sense. The second one is that a different catalyst was used in experiment 2. So that is also a possibility, because if a different catalyst is used, that catalyst might not function properly, and that would lead to a slower reaction. So that is also a possibility. The last one is that product S was continuously removed from the reaction vessel in experiment 2. So if you remove product S is over here. If you keep on removing this S from the equilibrium mixture, the equilibrium would shift in the forward direction. More products would be formed, but that is not going to affect the rate of the reaction, because the rate of reaction depends on the collisions between these particles P and Q. It's how frequently they're colliding or how effectively they're colliding. So it doesn't really depend on S. So the equilibrium is going to shift forward. There's going to be, the forward reaction would happen. The backward reaction would not be possible because there is no S. You're removing S. So that is why more products would be formed and the reactants would not be able to form back again. So the equilibrium part is correct, that the equilibrium would shift forward, but nothing is going to happen to the rate of the reaction because it depends on P and Q. It depends on the collisions between this. So S has nothing to do with that. So this third statement is incorrect. So 1 and 2 are correct, and B would be the correct option for this question.